Hello upper primary students, I'm Victoria Carthew. It's that time again and we have lots of interesting information in your English, math and science lessons today. We'll explore how we can experiment with figurative language to create imagery and influence others. We'll be looking at another way to multiply and we're going to take some time to think about different sources of energy. Let's start with English. Writers think carefully about the language that they use to create images and influence people on a range of topics. Today, Rebecca will explore how we can experiment with figurative language to create imagery and have an effect on others.
Hi everyone. Have you ever found yourself experiencing an overwhelming sense of happiness or excitement? Have these feelings ever been so great that you found it hard to express in words just how wonderful you were feeling? At times like these, when something is hard to describe, writers use figurative language to express their thoughts and emotions. For example, I might say, I'm a whirling rocket. I'm not really a whirling rocket, but this language captures just how excited I am. Whirling rocket is an example of figurative language. That is, language that is used in different ways to its literal or actual meaning to achieve a particular effect. Today, we are going to look at how to experiment with figurative language, such as similes and metaphors, to create imagery and influence others. Let's look at what this means by looking at some examples of figurative language. Similes and metaphors are examples of figurative language devices used to be more descriptive and interesting when creating imagery and influencing others. Do you know what a simile and metaphor are? Similes and metaphors are very popular techniques used in poetry and other forms of writing because they help us create mental pictures to process the meaning of words and ideas. They can lead us to see things in a new way. Let's take a closer look. Similes are used to make a comparison between one thing and another. This is done by using the words like or as. For example, Lexi sprinted to the school bus as fast as a race car. In this example, we don't really need to explain that Lexi is really fast because the simile helps us picture a race car, which we know is really fast. Note the use of the word as in this simile, suggesting that one thing, the girl Lexi, has the qualities of the other, the race car. In this case, the quality being compared is speed. This simile paints a picture in my head and helps me imagine just how fast Lexi is. What did you see? How about if we want to describe another quality? In this case, how clean sheets smell. What simile can you think of to describe how sweet, freshly cleaned sheets can smell? What did you think of? Maybe my sheets smell as sweet as roses, as an apple pie. How about the ocean breeze? Depending on our choice, we can influence people to visualise or see different pictures and make different associations or comparisons. Think of how this can be used in advertising to influence us to buy a product. Remember, a metaphor is another figurative language device that compares two different things. Instead of using words like or as, metaphors say one thing is another. For example, the toaster is a fire-breathing dragon. In this example, the toaster takes on the qualities of the dragon. This makes it easy for us to understand the toaster is burning hot, just like fire streaming from a dragon. Note the use of the word is in this metaphor, suggesting one thing, the toaster, is being compared to another, a fire-breathing dragon. Okay, why don't you have a go at creating a metaphor? Think about a classroom. How would you describe it so that someone understands what it feels like to be there when everyone is loud, noisy and busy, enjoying group work activities? What metaphors could you come up with? Perhaps you might say the classroom is a zoo, an adventure park, or maybe a roller coaster. All of these comparisons conjure different types of images that represent a hectic, rowdy, adventurous environment. But we can experiment with our language choices to have a different influence on the audience. For example, What if we want to describe a classroom where everyone is quietly working on an independent task? How might you describe this classroom using a metaphor? Perhaps you might say, the classroom is paradise, or a place of quiet mice, or even a silent forest. By experimenting with our language choices, we are able to represent an entirely different classroom environment. It's great to add some flair to your language using similes and metaphors. How could you use your newfound power to influence your readers? Figurative language, such as similes and metaphors, are used to create imagery and influence others. You can practice using similes and metaphors by finding objects around your home to describe, by comparing them with the qualities of something else. See how creative you can be with your comparisons. You might also like to look for examples of figurative language in poetry and in advertising. How did this language influence you as the reader? See you next time. Bye.
People have been using multiplication for over 5,000 years. We don't know from which culture the concept of multiplying originated because it can be traced back to many ancient civilizations, including Egypt, China, Babylonia and India. Each civilization used different strategies to multiply numbers. The ancient Egyptians used hieroglyphics to multiply in 1600 BC. And the use of times tables, like the ones we use, can be traced to ancient China. Let's learn more about applying multiplication strategies.
In mathematics and our everyday lives, there are many strategies we could use to find solutions to number problems. If we are familiar with a range of strategies, then we can choose the best one to suit a particular problem. In mathematics, we use special vocabulary. When we increase values many times, we use the word multiply. Today, we are going to use the area model as a strategy to solve multiplication problems. We're going to use 1 and 2-digit numbers. To multiply numbers using the area model, we use grid paper, or draw rectangles or squares to represent a multiplication problem. For example, 6 multiplied by 14 can be shown on a grid or as a diagram. See on the grid that the rectangle is made with one side being 6 squares wide and the other side being 14 squares in length. Now we know that if we counted each of the squares in the rectangle, we would find the solution to our multiplication question. But counting all those squares would take a long time, and we could easily make a mistake. So we're going to find the area of a rectangle instead. Remember that to find the area of a rectangle, we multiplied the width by the length. To make the sum easier, we can split the rectangle into 2 smaller rectangles. We use the place value parts to split it. 14 is 1 10 and 4 ones. So the length of the rectangle is split into 10 and 4. We can easily do the multiplication of 6 multiplied by 10, 60, and 6 multiplied by 4, 24. Then all we need to do is add the 2 rectangles back together. 60 add 24 equals 84. So we can say that 6 multiplied by 14 is 84. After some practice with the grid, we use a diagram to represent it. Let's try with 5 multiplied by 45. Our diagram is 5 squares wide and 45 squares in length. Then we split the rectangles into smaller rectangles using place value parts. 45 has 4 10s and 5 1s. so the length of the rectangle is split into 40 and 5. We do not have the grid squares to count this time, so we're going to have to calculate using area. 40 multiplied by 5 is 200. 5 multiplied by 5 is 25. When we add the little rectangles back together, we get 225. 5 multiplied by 45 is 225. Once we get the hang of a strategy, we can use it to efficiently calculate solutions. This means we can do this quickly without error. The great thing about the area model is, as one strategy, is that we can use it for bigger numbers too, such as 2-digit by 2-digit multiplication or 1-digit by 4-digit multiplication. Let's try it with 18 multiplied by 14. First, we draw a rectangle. Then, we split it using place value parts. 18 can be split into 10 and 8, and 14 into 10 and 4. Notice that the area diagram has 4 rectangles. Now we can see and multiply each of the smaller rectangles. 10 multiplied by 10 is 100. 10 multiplied by 8 is 80. 4 multiplied by 10 is 40. 4 multiplied by 8 is 32. We recombine the parts to find the total for 18 multiplied by 14. 100 add 80 is 180. Add 40 is 220. Add 32 is 252. Okay, let's really test ourselves to make sure we can apply the area model to a huge number. Take a look at this number. 4,863 multiplied by 8. Wow, this doesn't look scary anymore. We have a strategy we can use, the area model. Let's give it a go. This multiplication problem is 4-digit by 1-digit. Let's solve this one with the area model together. First, we draw a rectangle. Then, we split it using place value parts. 4,863 into its place value parts is 4,863. Now we can see and multiply each of these smaller rectangles. 8 multiplied by 4,000 is 32,000. 8 multiplied by 800 is 6,400. 8 multiplied by 60 is 480. And 8 multiplied by 3 is 24. We recombine the parts to find the total. 32,000 add 6,400 is 38,400. Add 480 is 38,880. Add 24 is 38,904. What we have done is used area model to calculate a huge number. We use this strategy to efficiently calculate a solution quickly and without error. Today, we use the area model as a strategy to solve multiplication problems involving 1 and 2-digit numbers, even 4-digit numbers. This method makes complex multiplication so much easier, and we can use it for almost any number. What is the largest number you can multiply this way? Have a go and impress your family. The next time we need to calculate how many sausages we need to buy, if everyone in our school buys 2, we can whip out our area strategy to calculate this answer. See you next time.
Using the area model as a strategy made complex multiplication so much easier to solve problems. Now it's time for our My Place segment, and this week we feature kids and teachers from Gracemere State School.
a long and rich connection to the Indigenous culture of the Durrumbal people.
Good morning, my name is Michaela, I'm 10 years old and my family lives on Durrumbal country. I have 5 brothers and 2 sisters. I can't wait until we learn Durrumbal language at Graceman State School.
Many students have completed their schooling through Graceman State School, providing our community with a link to the Indigenous students and their families.
Every year, all students are able to create a greater understanding of the Indigenous culture of the Durrumbal people.
A great example of this is our celebration of NAIDOC Week. Students engage in a variety of activities, emphasising the importance of sharing and continuing the understanding of our Indigenous culture.
To enrich Graceman State School as an inclusive community, we are working towards introducing Durrumbal culture and language into the curriculum in the near future.
This space.
Watch this space!
Watch this space, Graceman.
Watch your space.
Have you ever experienced a blackout when your home temporarily lost power? And can you imagine a world without electricity? So many parts of our daily life depend on it. The world's demand for energy is growing, partly because the world's population is growing, and partly because we have more devices that use electricity. Scientists have a challenge too. How do we keep making enough electricity for everyone? Today in Science, let's take some time to think about different sources of energy.
Have you ever heard of renewable and non-renewable energy? The energy we use for our day-to-day use can be produced in different ways. And you might have heard some of these terms in the TV news or in documentaries, read them in a newspaper or on social media. But what exactly do these terms renewable and non-renewable mean? A renewable resource is one that is produced, grown or replaced over a period of time at a rate that is faster than it is being used. These resources don't have a fixed or finite quality, as more can always be generated quickly. On the other hand, resources that are non-renewable means that they take a long time to be created. That means that they are used more quickly than they can be replaced. Remember my old friend coal here? The fossil fuels we learned about last time would be classified as non-renewable because, remember, they take millions of years to produce. Renewable energy resources can be used to generate electricity. They include things like solar power, wind power, hydroelectric power, tidal power and geothermal power. Let's spend some time exploring these 5 renewable energy sources. Have you ever seen solar panels on a roof, on a home or at school? This is just a smaller version of the ones that you would see there. You might have even seen them on a farm or in local businesses or on top of shops. Solar panels are known as photovoltaic cells. They convert solar energy into electrical energy. Solar energy is a renewable energy source because it uses the light and heat from the sun. That means it's continuously produced over time. There are about 32 operating solar farms in Queensland and 80 more planned. We're called the Sunshine State for a reason, after all. Now, another type of renewable energy is wind energy. Maybe you've seen large wind turbines like these. When the wind blows, it causes the blades of the turbine to move, and this movement is used to generate electricity. I can actually demonstrate it on this much smaller model. So here's the propellers, and when I blow, electricity is produced. I guess you'd call that green energy. Unfortunately, when the wind doesn't blow, you get no electricity. An area of land with a group of windmills or wind turbines is called a wind farm. There are 5 wind farms in Queensland, and you may have seen them. They look like this one. Around 15 more are planned, including another in the next 2 years on the coast near Maryborough, where there's plenty of wind. This wind farm is expected to produce enough electricity to power more than 500,000 homes. As well as solar and wind energy, we can also harness energy from moving water. This is called hydroelectric energy, and it has actually been used for thousands of years. Have you ever heard of the Snowy Mountains Hydroelectric Scheme? It's located in Kosciuszko National Park down in New South Wales, and it provides electricity to some of the major capital cities including Brisbane, Sydney, Canberra, Melbourne and Adelaide. Hydroelectric power stations like the ones you can see here collect large amounts of snow and rain that fall on the mountain ranges. It then channels that into dams. The movement of the water is used to move turbines that generate electricity. Remember, turbines are those big fan-like things. We can also generate energy from water that moves back and forth in tides. This is called tidal energy, and Australia is a world leader in tidal energy. The world's first installation of tidal turbines is located right here in Queensland at Gladstone. It was such a success that other countries have visited Australia to learn about this technology. The last type of renewable energy we're going to look at is geothermal energy. This is the natural heat energy located from deep beneath the Earth's surface. Geothermal energy is a very new industry in Australia, and scientists are still investigating how to locate this energy in Australia. So, watch this space. Okay, let's recap what we've learned today. We know that a renewable resource is one that is produced, grown or replaced at a rate that is faster than the rate that it's being used. Examples of renewable energy include solar power, wind power, hydroelectric power, tidal power and geothermal power. Australia is a world leader in the field of renewable energy. Good for us. And now it's your turn. When you next go for a walk through your local community, see if you can identify any solar panels on the roofs of homes, shops, schools or other buildings. You might actually be surprised at the number of solar panels you see. Thanks for watching and see you next time.
We've learnt about wind power, hydroelectric power, tidal power and geothermal power, and so many homes in Australia have solar power. Well, that's it for this edition of Learning at Home TV, but we'll be back soon with more lessons. In the meantime, stay safe and positive and make sure you look out for each other and keep practicing what you hear in the health messages. See you next time.
Authorised by the Queensland Government, Brisbane.